So the lesson we're going to do today is on quadratic functions. We're really looking at patterns and how where we add numbers in different places causes different things to happen to the function. So let's start with the basics. We have to know what a quadratic is. Now, some of you also know by the more common name, parabola. So you can always put that in there to remind you, and we should know kind of what shape it does. It should be the letter of the alphabet. We've talked about this before. It should be a U shape when I think about this. So if I add in these values, it just means I'm squaring it. Make sure you think about order of operation. So for example, when I plug this into squared here, I'm doing -2 in parentheses squared so that the negative also gets squared. So if I quickly square these, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. And if I graph it over here, I can quickly put in the points and make a smooth curve. Make sure it does not look like a V. That is a totally different function. It doesn't have to be beautiful or perfect, and we should have arrows on the ends. In this case, the y-intercept, again, where it crosses the y-axis is 0, 0. The domain, I can put anything in for x, positives, negatives, roots, fractions, anything I want. So my domain is x can be anything. My range, though, notice that it kind of has a minimum, and then it's going up from there. So my range is going to be y is greater than or equal to 0. If you prefer interval notation, feel free to do that. I'm going to stick with inequality notation. It asks silly questions like, is the graph linear or not linear? Remember, linear means, is it a line or not a line? This should be very obvious looking at the fact it's a curve. And if I looked at the chart, how can I tell? So I said from the graph, it's a curve. That's how I know it's nonlinear. From a chart, I can tell at the rate it's increasing or decreasing. So changes at a non-constant rate. So all of this pretty much you should have known before you walked in my classroom. Now let's start talking about how we manipulate it and do transformations, kind of like we did yesterday. So when I look at this, we're going to take the function, we're going to see what happens when I add 4 to the back or I subtract 3. So I'm going to start with the same values I had before. My x and y table. Actually, I'm going to do this in a beautiful, beautiful color here. Let's do it in red. I'm going to have -2, -1, 0, 1, and 2. So if I think about squaring -2 first, I get 4 plus 4 is 8. -1 squared is 1 plus 4 is 5. 0 squared is 0 plus 4 is 4. 1 squared is 1 plus 4 is 5. And 2 squared is 4 plus 4 is 8. So if I go to graph this, can we tell what happened? If I go to -2, well, 8's going to go a little off, but that's okay. -1, 5, 0, 4, here. What happened to my graph when I added 4? Can you tell? Well, if I look at my graph from above, all that happened is I took the same picture, but I shifted everything up. So what this says is when I have this value, it goes up 4. Every single value, I just added 4. Oh, well, that could make my next graph way, way easier because I don't have to do as much work. So if I want to do my next one, and notice what's going to happen, can you already predict what will happen with that -3? I hope so. If I plug in -2, let's just go through the process. -2 quantity squared is 4, take away 3 is 1. -1 quantity squared is 1, take away 3 is -2. 0 squared is 0, take away 3 is -3. 1 squared is 1, take away 3 is -2. 2 squared is 4, take away 3 is 1. Did it do exactly what you thought that it would do? And again, I hope so that you were able to predict what was going on. It did not change the shape, it did not change anything except for it went down 3. So can we make a summary statement? What happens to the parent function y equals x squared if you add or subtract a number outside the squared term? So plus k, remember we talked about this yesterday, goes up, minus k goes down. So if we said what happens if we add 2 compared to subtracting 2, graph shifts up 2 units versus graph shifts down 2 units. And again, this is really summarizing with a different type of function what we did yesterday. So what about some new stuff? Because you're sick of seeing the same old stuff. So when I look at this, now look what are we doing? We're multiplying by a number in front, including a negative one. So that's going to make a different thing. This is making it 4 times the original value. So if I go back and I do my x and my y, -2, -1, 0, 1, 2. I could go back to my original graph that was 4, 1, 0, 1, 4, multiply everything by 4. So this ends up being 16, 4, 0, 4, and 16. What did that do to my graph? Well, -2, 16 is too ridiculous to graph, so I'm going to go with this and just plotting these. Notice what it did to my graph. It made it go much, much steeper. It's like having a higher slope. So some people use the words steeper. Some people use the idea that it got closer together so that it's skinnier. They'll use those kinds of words. Can you already predict now when I multiply by a quarter? Well, it should do the opposite effect. So if I think about multiplying every number by a quarter for my original one, I'm going to get 1, 1/4, 0, 1/4, and 1. So I get -2 here, about a fourth. So again, what happened? I can even go further, right? If it was 3, it would be 9/4, so that's like 2. I mean, it's gonna really stay pretty wide here. Notice that it's not shifting up or down, left or right, but in other words, getting steeper. They say it's getting shallower is the opposite word. It's like the slope reducing, right? 1/4 has a totally different slope than 4. They also, some people are prejudiced, and say it's fatter. Kind of feel bad for the parabola. The last one that we have to deal with here is what if I put a negative in front? And so that means I'm multiplying, again, everything technically by -1. So if I think about those same values that we've been using, the 4, 1, 0, 1, 4, this is a negative after, so it means I'm adding a negative. I can't have -0, that's why that's still there. So what did it do? It kept the same shape, but it flipped it upside down. So this flipped. So let's talk about, again, in general, what happens. What happens to a parent function if you multiply a number in front? It changes the shape of my graph, of my parabola. Now, not to a new letter, just how wide or how skinny or fat, steep or shallow it is. So if I multiply by 2, it should get steeper, versus here it should get shallower. Again, steeper means it's getting closer together, shallower means it's getting wider apart. I'm exaggerating, but that's the idea. And hopefully you also notice that when it's negative, it flips. One last thing can happen, and that is, notice what's different than this compared to the first one? Now there's something inside the parentheses, not outside. There wasn't even parentheses before this. So if it's inside, it causes a different change. It means that I'm adding 4 before I square it, not after. So how does that affect my graph? So let's go back and look at this and see what's going to happen. So if I plug in -2, -2 plus 4 is 2, squared is 4. -1 plus 4 is 3, squared is 9. What do you notice? It's getting 0 plus 4, it's getting just bigger and bigger and bigger. But it has to come down, it has to be a U shape. So what must happen? If I keep looking at this, I go, well, I better go backwards a little bit more. So I'm going to add a few more values over here. I'm going to go backwards, and let's see what happens if we go down to like -3. -3 plus 4 is 1, squared is 1. Okay, we're getting smaller. What about if I plug in negative 4 plus 4 is 0? Ooh, it's still getting smaller. What about if I plug in negative 5? Negative 5 plus 4 is negative 1, parentheses squared is, oh, now there it is. There's my vertex. There's my bottom, my minimum. So if I were to graph this, I'm actually going to think about these ones I could actually put on the graph. So I'm going to start at negative 5, comma 1, negative 4, 0, negative 3, 1, negative 2, 4, and so on and so forth. So here is my graph. What did it do? So this negative 4 shifted the graph to the left, exactly. Trying to make you think about it. Can you already predict what the other one will do? So let's think about where we should look. Should I start with my same values? Probably not. How about instead, let's start with 0 and see if we can see where the change comes. If I put 0 in, minus 5 is negative 5 squared is 25. If I plug in 1, I get negative 4 squared or 16. 2 is negative 3 squared or 9. 3 is negative 2 squared or 4. Still didn't get down to that turning point yet, so I'm going to add some more values. 4, I get negative 1 squared or 1. Oh, I feel like we're getting close. 5 minus 5 is 0. Oh, there's my 0. There is my vertex. And then just to check, 6, I go back to 1. So I can see it rebounded back up. So now again, I'm going to plot the ones I can plot. So let's start with 3, 4, 4, 1, 5, 0, 6, 1, and we can see that it did probably what I hope you predicted it would do, and that is 5 to the right. So what happens when I add or subtract a number inside the squared? Okay, so what does that mean? Is that it shifts horizontally, right? If it's positive inside, what happened? It moved left. If it's negative inside, it moved right. And the last thing is to think about the domain and range. How is that affected by the different transformations? Now, I will already tell you the domain never changes. So the domain is always x equals all real numbers. Doesn't matter what I do to it, that's not going to change. But the range can change. Range changes with either a vertical transformation when we add it outside, because that's going to change it up or down, or if I multiply by a negative, like the one that was flipped, because we saw that flipped upside down, that's going to change your range. I hope this helps you get started on your homework tonight, and let me know if you still have some questions.